Coil A18 scanning now. Confirmed. AGV, proceed to Bay 3.
Imagine walking inside a massive, fully automated electric vehicle factory where thousands of parts move through a perfectly organized production system. Steel, aluminum, battery cells, electric motors, glass, seats, wiring, computers, wheels, and sensors all enter from different sections of the factory. But by the end of the line, they come together to become one complete electric car. The process starts long before any metal is shaped. Engineers design the full vehicle on advanced computer systems. They plan the body, chassis, battery pack, electric motor, cooling system, wiring, safety structure, interior, and software. They also create a digital twin of the factory, so every robot, conveyor, tool, and inspection system can be tested before real production begins.
The airflow here is turbulent.
Right. Let's smooth this curve. I'll run a new simulation.
The frontal crumple zone absorbs the initial impact.
And the passenger zone stays intact. Good.
What about the battery pack?
It's fully... This adjustment finalizes the flow for line 3.
Confirmed. Efficiency is holding at 94%.
Perfect. Roll it out.
Once production starts, raw materials and parts arrive at the factory. Every component is scanned, tracked, and sent to the correct production area using automated guided vehicles. This helps the factory know exactly which part goes into each car. The first major stage is metal stamping. Large coils of steel and aluminum are unrolled, cleaned, straightened, and pushed into giant stamping presses. These presses shape flat metal sheets into doors, roofs, hoods, fenders, floor sections, and structural supports. Robotic arms remove each panel while cameras inspect them for cracks, dents, or defects. Next, the panels move into the body shop. This is where hundreds of robotic arms weld, clamp, lift, and position the parts with incredible accuracy. The floor, side panels, roof, front structure, and rear structure are joined together. Spot welding, laser welding, and structural adhesive help make the body strong, safe, and stable. Scanners check every gap, weld point, and body dimension before the shell moves forward. Before painting, the body must be completely cleaned. It passes through washing systems, chemical treatment tanks, and an electro-coating process known as e-coat. This protective coating reaches hidden areas of the metal and helps prevent rust and corrosion. After curing in ovens, the body is ready for paint. Inside the paint shop, robotic sprayers apply primer, base coat, and clear coat in a clean, dust-controlled booth. Every spray pattern, distance, and paint thickness must be exact. After curing, cameras and light tunnels inspect the surface for scratches, dust marks, uneven paint, or color mismatch.
Initiating light tunnel scan. Scanning for paint defects. Defects detected and logged.
While the body is being painted, the battery area is working at full speed. Battery cells are tested for voltage, capacity, resistance, temperature behavior, and physical condition. Approved cells are grouped together and assembled into modules. Robots connect the cells using bus bars, tabs, or laser-welded joints. Cooling plates, sensors, wiring, and the battery management system are installed. The modules are then placed inside a sealed battery pack, housing and tested for leaks, insulation, voltage, and safety. At the same time, the electric motor and drive unit are assembled. Copper windings, stators, rotors, magnets, bearings, shafts, inverters, and reduction gears are fitted together. The drive unit is tested for torque, speed, vibration, noise, cooling performance, and efficiency. Now the vehicle moves into chassis and underbody assembly. Suspension parts, steering components, brake lines, cooling lines, high voltage cables, and the drive unit are installed. Then the battery pack is lifted from underneath and fastened into the floor structure. This is one of the most important moments in EV production because the battery becomes the main energy source of the vehicle.
Starting insulation test on the pack. Readings are stable, no breakdown.
Suspension and brakes locked in. Moving to next stage. Guiding main harness left to right.
Copy, threading support bundle.
Tools engaging, hold steady.
Secured, next phase.
The painted body then enters final assembly. Wiring harnesses, dashboard, touchscreen, seats, carpets, airbags, seatbelts, windows, mirrors, lights, charging port, cameras, radar sensors, wheels, tires, brake fluid, and coolant are all installed. Doors are reattached and carefully aligned. After the hardware is complete, the car is connected to factory computers. Software is installed, control modules are configured, the battery management system is checked, and sensors are calibrated.
Gaps are good, lock it in. Alignment confirmed, clear to proceed.
The vehicle then goes through full electronic diagnostics. Finally, the electric car enters quality testing. It is tested on a rolling road for acceleration, braking, steering, motor response, and regenerative braking. Water leak tests, paint inspections, panel gap checks, suspension alignment, charging tests, and final safety checks are completed. Only after passing every stage does the finished electric car roll out of the factory, fully assembled, tested, charged, and ready for delivery. From raw metal to advanced battery technology, from robotics to software, this is how modern electric cars are made inside a fully automated EV factory.
Motor torque is ramping up smoothly.
Brake force is responding well.
Let's check the stability curve. Light reflections are stable.
Cameras are scanning now.